Hello, everyone. Thank you for joining us and welcome to the Data Phoenix webinar. Today, we will talk about machine learning techniques in the healthcare industry. We have with us Dr. Shahid Mohammad Ganie. He's an assistant professor at the Woxsen University. If you have any questions, please ask them in Slido, the link you can find under the video. And now I can give the microphone to our speaker, and we can start.
Thank you for the nice introduction. Shall I start?
Yes, you can start.
So, am I audible?
Yes.
Okay. So, first of all, I will be give a brief introduction about me. I am Dr. Shahid Mohammad Ganie, working as an assistant professor in AI Research Center, School of Business at Woxsen University. Prior to joining Woxsen, I have completed my Ph.D. Machine Learning in Healthcare Informatics and my Master's in Computer Application, where I was a Gold Medalist from School of Mathematical and Computer Science, Baba Ghulam Shah Badshah University, Rajouri, Jammu and Kashmir UT. I also hold my BSc Mathematics from Kashmir University. My research interests include data analytics, machine learning, deep learning, medical image computing, healthcare informatics, and smart healthcare system. I have published more than 25 research articles in the referred journals, edited books, and reported international conferences. I also published two patents in healthcare domain as well. Additionally, I serve as a reviewer for international and national journals such as Journal of Big Data, Healthcare Analytics, Computer Materials, and Continua. Uh, as far as teaching is being concerned, I am having more than 2 years of teaching experience where I taught some courses such as machine learning, predictive analytics, big data analytics, advanced business analytics, and so on and so forth. In addition, I am a member of AI Research Center at Woxen University. I hold a research affiliation with the Woxen Future Lab, which is basically interdisciplinary, multidisciplinary research lab. Uh, Also, I am a I'm a member of the Technology Advisory Board at AI Research Center in Woxen University. In addition to this, I am a program director of MBA Business Analytics, School of Business, Woxen University. So this was all about my introduction, my academic career. So today, as far as this webinar is being concerned, we are having the title Machine Learning Techniques in Healthcare Industry. So first of all, I will try to go to the outline of my presentation. First of all, we will be discussing introduction to AI, machine learning, and deep learning. Then we will be discussing machine learning in healthcare. Also, we will discuss and we will talk about health data. What are the different sources of data that are available for healthcare industries and where we can apply machine learning tools and techniques. In addition to this, we will be discussing the current tools and techniques for healthcare data analytics. Followed by, we will be discussing some use cases, particularly for disease detection and prediction. Uh, and then we will be discussing the challenges in healthcare data, the challenges that are associated while dealing with the healthcare data. We will be discussing, and finally, I will summarize this presentation, and we will be discussing the conclusion and future scope. So, as far as machine learning is being concerned, basically it's a subset of artificial intelligence. So, it's better to discuss a little bit about artificial intelligence, then machine learning, and then deep learning. As far as this Venn diagram is being concerned, we can see and we can observe easily. Artificial intelligence is a superset. Inside artificial intelligence, we have machine learning, and inside machine learning, we can have a deep learning. So artificial intelligence is all about to mimic the human activities, and where we are trying to develop a framework with the help of software and with the help of hardware, and we are trying to mimic the human activities, especially the understanding, the rational abilities, this kind of stuff. So when we talk about machine learning, it is all about to learn from experience. The experience is nothing but actually data that we are feeding to the machine, and machine is learning from the data without being explicitly programmed the machine. So followed by, if we talk about deep learning, it's nothing but it's basically artificial neural network where we are trying to mimic the human neuron, and we call it as a artificial neuron. And if we try to increase the hidden layers of a artificial neuron, then it will become a deep learning. And nowadays in deep learning we have so many lot of tools and techniques. We have lot of algorithms. If we talk about artificial neural network, convolutional neural network, recurrent neural networks, we have nowadays we have transfer learning techniques in this field, in this subfield. So, talking about the types of machine learning, basically there are three basic types. Apart from these types, there are other types as well, but these are secondary types. These are primary types of machine learning, where we start with the supervised learning, semi-supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is all about when we have a data with labeling and we have a target variable with us, so we can apply machine learning with the supervised learning fashion. If we are having unlabeled data and we don't have a target variable with us, so at that time we can apply unsupervised learning. So in between there is another type, that is semi supervised learning, where we can have sometime we can have a labeled data, or we can have, if we talk about suppose we are having a data set containing 10 attributes. Out of 10 attributes, 9 attributes are 5 attributes are having label, and 5 attributes are having not label with it. So at that time we will follow this approach. We can go through the semi supervised learning as well. So in supervised learning, again we are having a two problem statements. We can have a regression problems where we are having continuous target variables, and another type is classification, where we are having a categorical, or we can have a discrete output in terms of 0 1, or in terms of scaling as well. So if we talk about semi-supervised learning, we are having both classification, clustering as well. And if we talk about unsupervised learning, we mostly follow clustering techniques, where we are trying to summarize data point based on their similarities, and followed by association rule mining we are having in unsupervised learning as well. So, if we talk about the algorithms that are associated with each and every learning mechanism, so we can start with the regression, where we are having linear regression, we are having ridge regression, we are having lasso regression, we are having polynomial regression. So, it depends upon the problem statement that we are using to solve with the help of machine learning. So again, if we talk about classification algorithm, we can have a k-nearest neighbor, support vector machine, decision tree, random forest. These are all the algorithms that can be used in the classification problem statements as well. So based on the unsupervised learning, if we talk about clustering, we have some clustering techniques. We can have k-means clustering, hierarchically clustering, density-based clustering. So these are all the algorithms that are part of different methods based on the learning fashion. So this is all about machine learning and types of machine learning. So nowadays, if we talk about additional types of machine learning, we are having right now active learning, transfer learning, federated learning. So these kind of learnings are basically a combination and collection of these primary types, where we have supervised learning, where we have unsupervised learning, and reinforcement learning as well. So next is all about how this machine learning works. What's overall methodology that we are tapping while we are using this machine learning? So it starts with the problem statement, or we can simply say define objective. So based on the problem statement, we try to present that problem statement with the help of collection of the data. That's another part. So collection of data is nothing but we are exploring the publicly available data, or even we can conduct the surveys online, offline, whatever the possible way we are having with the problem statement, we can use it. Then the third step is preparation of data, where we are applying some tools, some techniques to filter data, to improve the quality assessment of the data. So this is the third part. Followed by we are selecting a particular algorithm as well. The algorithm is nothing but it's a machine learning algorithms where we are providing the data, and based on the selection of the algorithms we are following training, testing, uh, or even we can say once we have selected the data, then we train that algorithm, or sorry, when we have selected the algorithm, then we train the algorithm and test the algorithm. These are the two steps that are very important part of machine learning process. And finally the last step is nothing but to integrate the model, or simply we can say in this step we are trying to develop a web based application or mobile based application that will provide a solution to the society, that will solve the problem that we have collected that we have defined at an initial state. So when we talk about this entire diagram, so it's nothing but we are having input data and we are providing data to the machine and we are selecting a machine learning algorithm, and at the top we can see we are having training data and test data. This is nothing but we are simply splitting our entire data set into the training phase and in the testing phase. In training phase we are basically try to train our machine learning algorithm that we have selected for the problem statement, and testing is nothing but we are trying to validate the model based on the testing phase or based on the test data as well. So again, from this diagram we can see after training the machine learning model, again we can provide an input, or input is nothing but we can again provide a test data to the model, and we can check the robustness of the model, reliability of the model, whether our model is working correctly or not. It's basically nothing but testing the model. So here in this example we are having prediction. Suppose we are providing healthcare data to the machine learning algorithm, and the data is related to the diabetes. In the training phase, machine learning algorithm is trained from the data 70%, 80%. There are different splitting ratios. Suppose we are providing 70% of the entire data for training phase and 30% of the data for testing phase. And here machine learning model will learn from and will get experience from the training data. Then we will provide that testing data to the model and we can predict whether a patient is having disease or not. And again it is a cyclic process where we are giving again data to the model, and model is learning from the data itself, and followed by we are testing the model based on the test data set. So if we talk about the role of machine learning in healthcare industry, so there are n number of processes where we can apply machine learning techniques in healthcare industry. I have coded some of them with this diagram. So first of all, we can use this machine learning techniques for disease identification and diagnosis. So we can work on diseases where we will try to identify the disease at earlier stages. We can try to diagnose the disease at earlier stages so that we can provide a better decision making pertaining to different diseases as well. Second step is we can also apply these machine learning tools and techniques for drug discovery and manufacturing. So where we can provide and where we can produce a composition with the help of these tools and techniques that will help us to discover new drugs, discover new medicines, discover new medical treatments that will help the practitioners or healthcare providers in a better and efficient way. The third one is nothing but medical imaging. Nowadays, if we talk about the data, so mostly 70-80% of the data is being generated with in the form of images only. So if we talk about medical imaging, we can have X-rays, we can have if we talk about CT scans, we are having X-ray, we are having. So this kind of stuff is nothing but medical images where we can apply deep learning techniques or machine learning techniques to classify the images and to identify the diseases as well. Even for cancer detection or for breast cancer, if simply we can call, or lung cancer we can call. Even in the pandemic as well, there were so many x-rays that are associated with the COVID. So with the help of these tools and techniques we can do, and we can perform medical image computing as well. So next is personalized medicine treatments, where we are trying to focus on the parameters. Parameters are nothing but parameters can be lifestyle parameter, or it can be a healthcare parameter. A healthcare parameter, or simply we can say pathological parameter. If a person is going for the treatment, he needs some, I mean to say, to conduct some lab tests. Okay, that's nothing but pathological data. Even we can work on lifestyle data as well. We can work on, suppose we can work on age, gender, we can work on heredity, gene, we can work on these lifestyle data. So in order to provide a personalized medicine and treatment for each and every patient, or simply we can say potential patient as well. So also we can apply these machine learning tools and techniques for smart healthcare records. So we know in our healthcare industries, data is being generated from multiple healthcare devices. So, and even we are having large databases that are available in the healthcare industry. So if we try to make smart classification of these health records, we can use machine learning techniques for the same. So finally, if we talk about disease prediction as well, I have some use cases I will be discussing in the upcoming slides or in the next slides. So where how we can apply these machine learning techniques for disease predictions. So now it's very important when we start exploring these technologies. It can, if it is AI, artificial intelligence, or machine learning, or deep learning, the first thing is data. So if we talk about sources of healthcare data, so I am having two images with me, one on left hand side and on right hand side. So if we talk about the leftmost topmost this diagram, so we are having medical images. Again, if we talk about X-rays, T scans, USCs, these kind of stuff we are having nowadays. We can explore these images and we can make predictions. We can diagnose a disease. Even we can extract the features from the image as well. This is the first source as of now in the healthcare industry, where practitioners or researchers are working with this data source. Second one is inpatient health monitoring. So we know if a patient is got admitted in a hospital or in a healthcare unit, so there are so many devices associated with the patient. At that time, we can generate again a large volume of data that's related to the patients as well. So it's again another data source where we can apply, and where we can use machine learning techniques to make better decisions to the patients that are admitted in a healthcare unit. So also you can explore examination healthcare data as well, or examination medical data as well. So basically, this is nothing but people, or simply patient or potential patient, try to visit to the doctors on weekly basis, or on monthly basis, or on quarterly basis. So they are providing a lot of information to the doctors, to the specialists. So it's again a very good source where we can apply machine learning, and we can do a better decision making to the patient's healthcare treatment. So again, patient generated health data, it's again a healthcare repository which generates a large volume of data, and it's treated as a very best source where we can apply these tools and techniques. So I talk about the laboratory results. We know this thing very well. Each and every patient must go to the pathological lab tests. So for these tests, as patient is also generating a large volume of data, and these labs are storing a large volume of data in their databases as well. So this data can be used as a source of the data as well. Now we will be talking about this diagram as well, where it's again we can have medical images, medical records. These are nothing but electronic health records we are having. This the data that is related to the patients. Okay, so genomics data we are having, omics, simply we can say RNA, DNA sequencing. People are working on this phase as well, where we are having omics data. So it is again a part of healthcare data. Mobile phone data, nowadays in our mobile phones we are having a lot of what we can say smart applications as well, or even we are using smart bands as well, where we are generating a large volume of data regarding to the healthcare. So this can be also treated as a source for healthcare data. Social media contents, sorry, social media data. Again, it's nothing but it's integration of IoT, Internet of Things, that are related to the healthcare only. Okay, these are all the devices that are associated with the smartphone, where we can generate a health data again, and it can be treated as a source to perform machine learning operations or to perform deep learning operations as well. The internet plays a very important role for the generation or for providing a large volume of data or even a heterogeneous data to the healthcare industry as well. So even we can generate this health data from the environmental data or even environmental devices as well. So this is all about the sources of healthcare data. Now, before going to discuss the use cases, it's very important to discuss the tools that are available where we can explore machine learning and where we can explore deep learning techniques. So, first of all, we will be talking about the tools followed by the programming language that are playing very important role nowadays in machine learning paradigm. And simply, if we talk about a data analytics portion, so with the help of these tools followed by programming language, we can make wonders. We can do perform analysis on the data. A data can be simply a numerical data. A data can be a categorical data. A data can be a text data. A data can be an image, simply audio, video, whatever. So with the help of these tools, we can do wonders, and we can provide solution to the problem statements, and we can pitch these solutions to the current society so that we can solve the problems of the common masses as well. So if we talk about the first tool, that is Anaconda, it's nothing but simply a data science community where we are having couple of open source tools. If we talk about Anaconda, it's completely a data science community where we are having integrated development environments, and we are having even programming languages as well. It is open source software. People can use it, and they can explore the machine learning algorithms. They can explore the machine learning techniques. They can even explore the statistical tools and techniques as well with the help of this software. So the second one is scikit-learn or science-kit-learn. It's a very good repository, or we can say web repository, where we are having each and every package that can be installed, that can be explored, that can be imported to perform machine learning work. So followed by we are having Google Colab. So this service is being provided by the Google, where we can explore the resources in terms of hardware or software. Even we can simply call in terms of memory and CPU utilization. So this type of tool will help us to perform analysis on the data with the help of machine learning tools as well. Followed by we are having Keras. This Keras is nothing but it is a very important library for deep learning techniques. Okay, where we can explore all deep learning algorithms followed by transfer learning techniques as well. If we talk about transfer learning techniques, we are having right now ResNet, EfficientNet family, ResNet family. We are having DenseNet family. We are having MobileNet family. We are having. So inside these families, we are having so many algorithms that can be used with the help of this Keras library. Even this library can be used for feature extraction as well. Pre-processing we can do easily with the help of this library. And followed by we are having TensorFlow. It's a part of this Keras. It's a sub part of this Keras as well. So again, we are having some another tools, PyTorch, which will help us to make end-to-end machine learning modeling, where we can have problem statement. We will perform data analysis, then followed by model building through machine learning techniques, and then we can build a web application or mobile application as well. And people are from last 10 to 20 years, people are using MATLAB as well. That's nothing but matrix laboratory. This can be also used to perform machine learning operations as well. Followed by we are having Veka tool, the University of Waikato. This tool is again used for this machine learning task as well. So now, based on this Anaconda, I have mentioned some of the core packages that plays very important role. in order to perform the task that is being done by the machine learning algorithm. So in Anaconda, we can use this pandas library. This is nothing but read, write the data sets, and to deal with the data sets, this kind of libraries we can use. Then followed by we are having NumPy. This NumPy is nothing but numerical Python, where we can perform numerical calculation, where we can perform numerical calculations to the data. So we can perform descriptive statistics, we can perform inferential statistics as well with the help of this tool. And then followed by we are having SciPy, which is scientific Python. If we try to explore the linear algebra or statistics in depth, we can use this kind of package with the help of Anaconda itself, and we can do the task of scientific calculations as well. So followed by there is a very big package that's nothing but matplotlib package, which is used for the data visualization. If we try to visualize data in the if we talk about Google Colab or in Anaconda, we can use Jupyter Notebook, we can use Spider. So this kind of library can be used for the visualization purpose. So based on this scaling, we can say if we try to explore the machine learning tools and techniques. These are the programming languages that they support us, and with the help of these programming languages, we can develop these models. And Python, R programming, SQL, Scala, SAS, and Julia. These are the all programming language that can be used based on the expertise. If somebody is comfortable with the Python, they can use a Python. If somebody is comfortable with R programming, they can use R programming as well. But also we can use SQL, Scala as well for machine learning kind of tasks. But as far as all programming languages are being concerned, so these are two very important languages, Python and R programming, that can be used for this kind of task. So followed by we are having what kind of analysis we can perform if we are having these number of tools and techniques. So we can do descriptive analytics, where we can understand the historical trends, we can provide answers to the questions. We can also do predictive analytics, what will happen in the future, we can forecast the future as well. And also we will work on the prescriptive analytics as well. What precautionary measures will we need to take in the future in order to solve or tackle any problem. And discovery analytics, nothing but itself is a research, where we are examining and determine what to explore the next. So based on these tools and based on this analysis, we can conduct these kind of services in healthcare industries. We can researching cures for cancer. We can conducting early detection of diseases. We can improve patient documentation. We can make smart electronic health records as well. We can even with the help of these types of analytics, we can do telehealth services. We can deliver very good telehealth services. Patients can sit at their homes, and we can provide better service to the patients as well. We can even remove human biases for better outcomes as well. So if we work very rigorously, or if we try to explore data in depth, we can provide a better decision, and we can support healthcare providers or even practitioners as well to provide a better decisions regarding the disease as well. Even with the help of these data analytics types, we can reduce the costs of hospital readmissions. This very big challenge right now, because cost is very important. Cost for the medical treatments and even hospital readmission cost is very important factor. So if we try to explore these kind of analytics, these all types of analytics, we can try to solve these kind of problems as well. So am I audible? Shall I continue? Hello.
Yeah, yeah, you can also go.
Yes.
Yeah, you can continue.
Hello.
Yeah, you can continue.
Okay. Thank you, sir. So now I will be discussing some use cases where the first case is for diabetes prediction. So we have conducted a survey from Jammu and Kashmir, India, where we have collected lifestyle data through online and offline mode as well. So for offline, we visit nearby hospitals, collect the data, and through online mode, we collect the data from different stakeholders of different departments. So also we have published a research article in elsewhere. Healthcare Analytics is the name of the journal. So in this research, we have collected 1939 records where we are having 11 attributes. So based on machine learning techniques, we have first prepare the data where we have filling missing values, we have detect outliers, we have also tried to remove and replace the corrupted data, the missing values, and the outliers as well. This was the first part. That's nothing but data pre-processing. Then followed by we have applied some machine learning algorithm using ensemble approach. Ensemble approach is nothing but simply when we try to combine more than one machine basic machine learning algorithm, we call it as an ensemble method. So for ensemble techniques, we had applied. I mean to say this bagging, boosting, and voting. These are three methods of ensemble approach we have used in our research. In bagging, we have used bagged tree, we have used random forest and extra tree. In boosting, we have used ADA boost, and in Scott gradient boost as well. And in voting, we have used logistic regression, decision tree, and support vector machine. These are all the classifiers that we have used. Followed by we have split our data first into the training and testing, followed by validation as well, where we have trained these all algorithms one by one, and followed by we have done some hyperparameter tuning as well. And based on training and validation, we have provided test data, and we have test all the models, we have evaluate the results, and we have compute the performance evaluation of each and every algorithm, and we have compare all the models, and we come up with the prediction of type 2 diabetes mellitus with best algorithm out of all the ensemble learning techniques. So as far as training, validation, and test is being concerned, first we have split 70 10 and 20, where we have applied 70% for training, 10 for validation, and 20 for testing. And again we have done 60, 10, and 30, and out of both these combinations we come up with 60, 10, and 30, where we have provide where our model have provided better results. As far as k-fold cross validation is concerned, we started with k value equal to 5, and we uh, close our k loop at 10 and k equal to 10, where we have provided our best results. So as far as all these techniques are being concerned, the best results we have achieving through bagging method, and where we have used a bagged decision tree, and the accuracy of the model was 99.41. This was the first study we have conducted, and this is all about a diabetes prediction using lifestyle data. So this is the next research work that we have done using machine learning in healthcare. So this use case is all about heart disease prediction. So where we have explored the publicly available data set from Kaggle UCI machine learning repository. Again, in this, we have applied some boosting techniques or boosting algorithms, where we have explored gradient boost, XG boost, and ADA boost. So here we focus on first part, followed by the model building. In the first part, we use not pre-processed data and pre-processed data both, and we compare the results as well. And we found there is a large difference in the results when we perform pre-processing on the data as well. So in pre-processing phase, we remove and replace outliers, we remove and replace duplicate values and corrupted data as well. We identify the missing values, we replace these missing values with computation methods. So as far as data is being concerned, again we are having in this research 13 to 1329 records, and followed by 14 attributes as well. So again, we perform the crayfold cross validation along with training and testing of the data, where we are having different splitting ratios. And out of this ensemble learning techniques that we have employed in this research, we got best results with the gradient boost, the first algorithm. The accuracy is 92.20. So this research we have published in Tech Science Press. The impact factor of this journal is 3.7. So this is an essay journal as well. So this was the second study that we have conducted with the use of machine learning in healthcare. So this is a third use case that's basically for chronic kidney disease prediction. So again, we have explored some basic machine learning algorithms. These algorithms are nothing but logistic regression, Navi-based classifier, support vector machine, and decision tree. So here we explore the publicly available data set that's available at Kaggle UCI machine learning repository. Total number of records present in the data set are 400, and total number of attributes are 25. And here we again check for missing values, outliers, duplicate, and corrupted data. This is nothing but exploratory data analysis, where we are trying to improve the quality assessment of the data, followed by we have split the data into training and testing phase, where we have applied all these models for first training phase, then followed by testing phase. And based on these testing phase, we have validated our models. We have compared the performance evaluation of each and every model. Here we have used four models, followed by we have predict the kidney chronic disease. So as far as all the algorithms are being concerned, we achieved a better results with the help of decision tree. With the accuracy of 99.17. So this paper we have published in one of the international conference on artificial intelligence theory and application, which was hosted by IBS Bangalore in August 11 12, 2023. So now there are some operations that are very important while developing machine learning model for healthcare data. So first of all, we need to perform EDA, exploratory data analysis, where we need to improve the quality assessment of data. We need to make data pre-processing, data wrangling, data manipulation. So we need to remove the missing values present in the data set, the outliers, the corrupted data. So these all kind of stuff we need to remove and replace, so that we can improve the quality assessment of the data. This is a very basic, important operation while implementing machine learning models for any domain. Even if right now we are talking about healthcare industry, so if we try to explore the healthcare data, we can perform this operation at initial stage. Second is class balancing. It's very important. So if we are having a data set of 100 records and we found 70% of records are only for diabetic patients and 30 are for non-diabetic patients. So balancing is a method that we can use, where we can apply oversampling and undersampling techniques. And in oversampling we have so many techniques, and in undersampling as well we have a lot of techniques that we can use, so that we can make a class balance, or we can make a target variable in a balanced nature. So this is again a very good operation that need to be performed, that need to be done before applying machine learning models. The third is data splitting. It's very important phase. So we can commonly we are splitting data into a training, validation, and testing phases. Or even we can use entire data for training. We can collect more data. We can use it for testing. It depends upon the availability of the data, what kind of splitting we can do. So followed by hyperparameter tuning. It's a part of machine learning models, where we are providing some parameters to the models during training and testing. So hyperparameter techniques, we are having a lot of hyperparameter techniques available in the tools and techniques that we have already discussed. So we can explore these hyperparameters, and based on the results of model, we can tune them, we can fine tune them, and we can come up with the good results. Again, it's a very important operation that need to be done before applying machine learning models. followed by feature selection and ranking. Suppose we are considering 20 features or 20 attributes to identify a disease, and we came to know, okay, out of 20, 15 are only important and 5 are not important for the disease, for diabetes, for heart disease, or for kidney chronic disease. Again, we are having a lot of methods in uh, machine learning, or we are having tools and techniques, even we are having packages as well, where we can make a feature selection and where we can rank the features as well, in order to identify which feature is contributing towards a disease and which feature is not contributing towards a disease as well. So followed by, we can have another operation which is nothing but performance evaluation. So it's nothing but where we are trying to explore various machine learning or statistical measurements. For example, we can say accuracy, we can say precision, we can say recall. So these parameters we can, these performance evaluation metrics we can calculate. So again, it's a very important operation in machine learning model building process. So followed by, we can have a k-fold cross validation. So this validation, we are having so many validation techniques. Here I have mentioned k-fold cross validation. So through this validation technique, we can remove complete biasness in training testing as well, where we can provide each data pin for training as well as testing, so that each and every record will be part of training and testing as well. So finally, when we do this lot of exercise while developing the machine learning models to solve a particular problem, or even we can say if we try to identify a disease, diabetes, heart disease, etc., so then we need to deploy the model as well. So here we need to integrate various web, so I mean to say various packages, where we can develop web application or mobile applications to provide a solution for the healthcare industry. So these are all the important operations that need to be incorporated while developing machine learning models for healthcare industries or even for other domains as well. So if you talk about performance evaluation matrix, we have heard about the confusion matrix. So confusion matrix is very core pillar. Through this confusion matrix, we can calculate other parameters as well. We can calculate accuracy, we can calculate recall sensitivity, we can calculate precision, we can calculate specificity. So is confusion matrix nothing but it's an example of binary classification. That's why we are having 2 cross 2 matrix. So it's nothing but here we are trying to map the actual values with the predicted values. So okay, if we talk about the first quadrant, here we are having true positive one on both sides, predicted value one and actual value one. Means the patient was this patient was pregnant and our model predicted as a pregnant. It's a good classification, it's a correct classification. And in the at the same, if we talk about this one, true negative, the actual value was zero and the model predicted it as a zero. So this means it's again a correct classification. Okay, this patient was not pregnant, and this again a good classification. So if we talk about these two quadrants, these are nothing but misclassification. Actually the patient was having disease, the model does not I mean to say predict it predicted as no disease. Here if we talk about this one, the actual value was zero, means this patient was not a pregnant, but our model predicted as a pregnant. So these are nothing but true positive, true negative, false positive, and false negative cases. So with the help of this confusion matrix, it's nothing but used to evaluate the performance of a machine learning model or a machine learning algorithm. So with the help of this, we can calculate these number of evaluation parameters that are very important to justify our model, that plays very important role in order to show the reliability and robustness of the model. So now if we talk about the challenges that are associated with the healthcare data, so first of all, it is data quality and integrity. We know this thing very well. Data is right now in healthcare industry. Data is being generated from multiple sources with heterogeneous kind of stuff. The data can be inaccurate, incomplete, inconsistent. Okay, so data can significantly impact the reliability of analysis and decision making. So we need to work on this phase as well, so that we can improve the quality of the data. We can integrate data in a better and efficient way. This is the first challenge associated. Second one is, as far as this healthcare data is being concerned, it's all about sensitive data. The privacy and security issues are very important things. So patient data is sensitive and must be handled in accordance with strict regulations. So we need to follow some regulations while exploring the patient's data. The third one is interoperability, which is nothing but we know this thing very well. Healthcare data often exists in disparate systems and formats across various providers and institutions, leading to challenging sharing and integrating data. So we know this thing very well. Based on the heterogeneous geneity of this healthcare data, sometime we need to map medical images with the text data. We need to map numerical calculations of lab with the x-rays with the medical image as well. So at that time we need to focus on the core aspect, basically where we will get actual data, sorry, we will get actual information. We need to integrate different formats of the data as well. The third point is regulatory compliance. We know this thing very well. Healthcare data is subject to various regulations such as HIPAA, Health Insurance Portability and Accountability Act. We need to follow that in US. And also we need to follow GDPR, General Data Protection Regulation. That's basically a regulation formed by the European Union. So this again a challenge while applying machine learning algo, while applying these deep learning techniques in healthcare industry. So followed by I talk about the data volume and the complexity. We know this thing very well. Nowadays, 90% of the healthcare data is being generated from diverse sources, such as electronic health records, medical imaging, genomics, wearable devices, health IoH, Internet of Health devices. So managing and analyzing this complex data is again a challenge. So last challenge is data bias and fairness. So we know this thing. Once we have collected the data, we need to remove the biasness first. Okay, so we need to pre-process the data in such a way so that while developing the models, there must not be any kind of bias or variance, or even we can say we need to take care of model building process as well, whether we are using accurate data, we are using unbiased data while we are developing these models, so that in the next process when we try to predict or identify some diseases, our model will come up with the good results, and it will help these healthcare providers, practitioners to make better decisions regarding the disease as well. So this was all about the challenges that are associated in healthcare data. Now I will be discussing this conclusion and future scope. So machine learning techniques and tools are being explored and used in each and every sphere of the world, and in each every domain as well. So if we talk about machine learning in healthcare, we can explore this machine learning by enabling predictive analytics, personalized treatment plans, and efficient diagnosis as well. Its application is in analyzing medical images has significantly enhanced disease detection accuracy, while predictive models help foresee or forecasting potential health risks in patients. Even with the help of these tools and techniques, we can bring awareness to the common masses. And we know this thing very well. When a patient, sorry, if a person is having some symptoms, he or she will then only to go and visit to the nearby hospitals or healthcare units. But with the help of these tools and techniques, we can bring awareness to the common masses. We can identify, we can diagnose, we can predict the disease at earlier stages, so that the patient can delay the conception of disease in nearby future. Additionally, machine learning algorithms streamline administrative tasks. We know this thing very well. If we try to apply machine learning algorithms in a large volume of electronic health records, we can optimize the process of administrative work, administrative tasks as well, or even optimizing hospital operations and resource allocation in a better and efficient way. So as far as future scope is being concerned, so we can integrate these machine learning techniques and tools, and we can expand data sets, or we can try to collect more data regarding the diseases as well, so that we can improve the results and we can ensure robustness and interpretability of the models as well. Moreover, we can also integrate the natural language NLP. That's basically right now, if we talk about the prescriptions, or if we talk about the medical reports as well, so we can also extract the text from the pathological tests as well, and we can understand the unstructured data as well from clinical notes and research papers as well, so that we can provide better results. Collaboration between healthcare professionals, data scientists, and technology experts will be the pivotal in harnessing the full potential of machine learning, ensuring ethical considerations and privacy measures are upheld while maximizing its benefits in the healthcare domain. So this can be also done in the future, where we will try to make a collaboration between different experts, between technocrats, between doctors, practitioners, or healthcare providers as well, so that we can provide a better, we can develop a better framework for better treatment. And even I talk about in the very beginning, we can reduce the costs, we can optimize the operations of the healthcare services, we can make better predictions, better treatments as well. So this can be done in the future if we try to collaborate with all the stakeholders. Thank you. This was all about my presentation. So now the form is open for question answer sessions. So please.
Thank you really much. Uh, Thank you for this exciting overview of using machine learning in healthcare. It was a wonderful presentation with really deep explanation and many examples. Thank you really much. And now let's answer the questions that we have on Slido, because we collected many of them.
Okay.
So, and you will reply.
I am able to see. I see one question. How much data do you actually need for from one
Okay.
patient to determine if has a
Let's start
disease?
from the first one.
Okay.
Inside the ML in healthcare, there are 6 tasks. For each task, where I can find those datasets to.
Hello.
Can you hear me?
Yeah, yeah, yeah.
I think I lost connection. Okay, let's reply on the first question.
The first question is in slide machine learning in healthcare. There are 6 tasks. For each task, where I can find those data set to build a model. Would you like to recommend any data set? Thank you. So I will try to explore the slide number machine learning in healthcare.
Mm-hmm.
Okay, so here uh, simply we can explore machine learning for disease predictions. If we talk about multiple chronic diseases, diabetes, heart disease, kidney disease, lung cancer. So nowadays we are having top 10 diseases that have affected globally, and where we are having death rates as well. So we can explore publicly available repositories. Kaggle is a repository, Google Data is a repository. On GitHub we can explore the data sets, and we can start working on disease A, B, C, D.
Okay, thank you. Let's go to the next one.
what use cases of using generative AI in healthcare will be relevant in the niche. Okay, so if we talk about the generative AI and all kind of these prompt engineering kind of work, so near future we can provide better assistance. uh, we can provide I mean to say we can provide better services as well. So it again depends upon the data availability that we can explore through this generative AI. Yes.
Okay, thank you. And let's go to the next one.
Concerning the imbalanced data set in case of diagnosis of rare diseases such, should we balance the data set before training? Yes, of course. So first we need to try and we need to conduct the survey where we will try to get a good mixture of all the patients. Suppose if we talk about to conduct a survey for diabetes, we need to uh, take this thing in mind that we need to have a good collection of patients where we are having patients with diabetes, patients with non-diabetes as well. Good mixture of demographic people we must have, and we can do at a very initial stage. Then after if we come up with the unbalanced data set, so at that time we can apply these balancing techniques before training and testing as well.
Thank you. If you don't mind, the next one I would like to read. Okay.
Okay.
In case of diagnosis rare diseases, balancing the dataset doesn't have a negative effect on application of the trained model on the future real-world data.
Yes, of course, that's what I am asking. It
Uh-huh.
must have negative. That's a reason to conduct the survey and to explore the publicly available data set. But if we talk about this class balancing, we can apply this on only training phase, but not on the testing phase. So, in order to make augmentation of the data, we can do it on training phase only. But as far as the testing phase is being concerned, so we can explore the original data.
Thank you. Oh, here is really small question. On what devices can machine learning techniques be implemented in the healthcare industry?
Already, there are a lot of devices in healthcare industry where machine learning is already being implemented. So, if we talk about disease monitoring, or if we talk about ICUs, we are having a lot of equipments where machine learning is already being implemented. And also, we can develop models, we can develop frameworks as well, and we can push them into the market in the healthcare industry. Suppose for disease diagnosis, and even I show my one of the case, it was health lifestyle data. We can conduct the survey on lifestyle data regarding disease A, B, C, D, and we can develop a complete web application or mobile application with the help of machine learning, and we can bring this into the market as well.
Thank you very much. And the last one is in performance evaluation metrics between recall and precision, which case that we use the metric example precision, or rather the other one, it's recall.
Precision and recall, I will be sharing again. These are two different matrices, and see, simply if we try to differentiate them, sensitivity or recall is nothing but true positive upon true positive plus false negative. Second one is working on true positive true upon true positive plus false positive. There is a difference between false positive and false negative. So if we talk about precision, it is all about false positive rate. That means actually the patient was not having disease, but our model predicts. So simply these are two similar cases we need to consider during model building process. So precision focus on false positive and recall focus on false negative out of all actual true positive cases.
Thank you very much. Since our audience still have a last question, It's how much data do you actually need from one patient to determine if he has a disease?
So it depends upon the disease as well. And even if we try to explore only one patient, so I think we cannot explore completely a machine learning tool and technique in healthcare industry. Data is very important aspect, and data is very important thing. So far to conduct this survey, so it depends upon the disease as well, how much data we require from one patient to identify the disease. So I cannot say this thing we can directly apply machine learning technique, but for machine learning we need much data to build the model.
Thank you very much. And thank you everyone for being with us today. Everyone who was leaving questions, really interesting questions for us. And
Thank you very much for providing me this opportunity to discuss my research area and to discuss how machine learning techniques can be explored in healthcare industry, so that we can help healthcare providers, practitioners, researchers in healthcare domain, as well as how we can help patients and potential patients, so that they can monitor and manage the disease at earlier stages as well. So once again, thank you very much for giving me this opportunity to represent my work and to discuss the role of machine learning techniques in healthcare industry.
thank you for coming, and see you all on the following webinars.